Hi, 8th graders. For this lesson, you were not given a note catcher. You're actually going to have to take notes with your own paper. So hopefully you can grab some lined paper, would probably be easiest, but any kind of paper would be fine. I know there's some space on the back side of your practice work with that green sheet of paper, but I would probably not do that. I don't think it'll give you enough room. So you can pause the video, grab something to write with, grab a piece of paper. And when you come back, we're going to title this. For those of you in Group A, you'll be doing this assignment hopefully Friday, September 11th. If you're in Group B, Tuesday, the 15th. Remember, we want you to have all of your remote lessons done before your next in-class session, okay? Anyway, this is called dimensional analysis, which sounds really fancy, but it's going to pick up where Ms. Faulkner's lesson left off, where you were converting units of measurement. And we're going to add a new layer of difficulty. It's going to be not one unit of measurement, but two, so a ratio, all right? So our learning target is that we can convert units of measurement or rates by using unit multipliers. Now, it's okay if you don't write down that learning target, but I want you to know what it is while we're running through this. There's some pre-thinking I want us to do before we get to the notes. If you don't want to write these things down, you don't have to. I'll let you know when you should start jotting some things down, okay? So some pre-thinking just to get our brains moving in the right direction. If we had 2/3 times 3/5, that would equal 6/15, right? Now, if I'm going to simplify this, what I'm technically doing is finding a number that would divide into 6 and also divide into 15. And that would be 3. And so 3 in the numerator and 3 in the denominator, right? Whatever you do at the top, you have to do the bottom. And that would simplify us to 2/5. Now, the reason I wrote this in red is because this right here, because the numerator and the denominator are the same, is just a unit of 1, isn't it? 3 over 3 equals 1. And when we divide something by 1, it doesn't change it. If we multiply something by 1, it doesn't change its quantity, right? So that's kind of a key component to this lesson, all right? All right, let's try another one. 3/7 times 1/3. Now, yes, we could go across and say 3 over 21 and then do that division. But like up here, I could have cross-reduced beforehand, and then I would avoid doing this reducing later. So it's just a quicker method when we're multiplying, that instead of reducing the end result, our product, we could reduce our factors. And because order doesn't matter in multiplication, I can cross-reduce as well. So technically, this can be divided by 3 here and here, resulting in 1, and 1 times 1 is 1, and 7 times 1 is 7. So 3 over 21 would reduce to 1 over 7, but we reduce it before we multiply versus when we're done. Okay. One more. Do you know the definition of a reciprocal? So most people can tell you what a reciprocal is. You say, oh, well, what's the reciprocal of 1/3? You probably would say 3 over 1. But why? So definition of reciprocals is that reciprocals actually multiply to equal 1, right? And we just said up here, 3 over 3 was 1, right? So definition of reciprocals, they multiply to be 1. All right, all that's pre-thinking. Now we're going to kind of dive into the lesson itself. So if you haven't started writing yet, it's time, okay? We want to really focus in on what, if you looked at the target, it's about unit multipliers, right? So what is a unit? Well, it's 1, okay? Anything, a unit is per 1 or just 1. So 1, this, for example, is 1, right? This is 1. Anytime the numerator and denominator are the same, it's going to equal 1, right? And this is really big when we are solving equations because if I'm trying to find the numerical value of something, its identity, that property is really important. It's called the identity property of multiplication. And multiplying, what can we multiply something, what number can we multiply something by and have it maintain its identity? It's 1. Now the additive identity would be, we could add 0 and it wouldn't change, right? We're going to focus on multiplicative identity properties today. Okay, so with that in the back of our head, we are going to use unit multipliers. So that was up in our learning target, right? Unit multipliers. So a unit multiplier is just 1, but we're expressing it as a ratio. So it's a ratio, just like these, that's equivalent to 1. So we're using this property to help us do some converting today. So for example, if we wanted to take 2/3 and come up with an equivalent fraction, right? Maybe we want to find a common denominator, for example, okay? Maybe we want the common denominator to be 12, right? Well, what do I multiply 3 by to get 12? Well, we'll be multiplying by 4 here. And if we want it to be equivalent and not change the quantity it represents, right, then technically I have to be multiplying by 1, right? So we call this the big giant 1. And when we multiply by 1, we don't change the quantity. This is the same quantity, aren't they? These right here, they're equivalent, meaning they're the same. So the quantity they represent is still going to be the same, even though we multiplied it, okay? Now, the way we use it when we're talking about measurement or units of measurement, labels are really important now, okay? So for example, let's do some examples over here. Examples. About 1 yard. Same as 3 feet. You see how the labels are important because 1 and 3 are not going to be equivalent, but 1 yard is equivalent to 3 feet. Okay, so equal to 1. Right? How about 12 inches? Equal to 1 foot. So we have 12 over 1 is a unit multiplier. It's equivalent to 1 because we're talking about inches and feet. How about 2 quarts is equivalent to 4 pints. That's a unit multiplier when we include the labels. Let's do a time one, 365 days. It's equivalent to 1 year. So all of these ratios are equivalent to 1, and therefore we can use them as unit multipliers to create an equivalent or similar or the same quantity, okay? All right, so let's do an example here, right? So number 1, if we were told to convert 4,000 ounces to pounds, Now this is a problem that you could have done yesterday with Miss Faulkner, right? We're just converting from one unit of measurement to another. But you probably didn't do it with a unit multiplier. So when we use unit multipliers, because they're ratios, we have to set up our problem as a ratio. So we start with 4,000 ounces. Really important that we include the label. And that's just, we're going to make it into a fraction over 1, right? Because we want to multiply it by a fraction. So we're going to multiply this by some version of 1, where the numerator and the denominator are the same. And what I want to do is get rid of the ounces. Okay, so just like we did up here when we were doing some canceling, right? I want to cancel or move away from ounces. And so I'm going to put it here in the denominator so that it can cross cancel the label now. So if I'm trying to move it to pounds, I'm going to put pounds up here. And so what unit, comparing ounces and pounds, would be equivalent to 1? Well, hopefully you know that 1 pound is equivalent to 16 ounces. So this is a unit multiplier. This is equal to 1. And when I multiply top times top, numerator times numerator, and bottom times bottom, denominator times denominator, I get this. But in terms of a label now, my ounces, the labels themselves canceled out. And what's left is pounds. So this unit of measurement now, I'll write it there, is pounds. So I was canceling, cross-canceling, not cross-reducing, but cross-canceling, okay, my unit of measurement that I wanted to move away from. And that gives me then, if I simplify, 250 pounds. Okay, so this is kind of new, I realize. Wait until we go through a couple more before, you know, you get nervous or anything. It's going to be good, right? I want to take a little break, maybe stretch, flip us over to the other side here, okay? Okay. Let's do a second example. So example 2. We are going to convert 100 kilometers, sorry, per hour. Now we have a rate to, and instead of writing it over here, I'm going to write it underneath. This is just a strategy. Miles per hour. So strategy, because then I'm putting the distance, which is in the numerator, and hour, the time, which is in the denominator, kind of lining up, seeing what I'm moving from and to, all right? All right, so we just start with taking our 100 kilometers per hour and expressing it as a fraction. So 100 kilometers per 1 hour, okay? And I'm going to be trying to move to miles per hour. So I don't have to change my unit of time. It's just the distance measurement I have to change, okay? So we're going to use some kind of unit multiplier. And remember, if my goal is to eliminate kilometers, the unit multiplier I choose has to have kilometers down here in the denominator, so that when I multiply across, it's the label that gets canceled, okay? So if I'm moving from kilometers, do we know something where we can convert kilometers to miles? That's the quickest way. Now, sometimes it's going to take more than one multiplier to get us there, but this one I have written down, and you should have a list of common customary units and metric units and their conversions so that you can pick the appropriate one. And so what I would choose is this 1 kilometer is equivalent to 0.621 miles. Again, I wouldn't be able to do this if I did not have the table with all the conversions, okay? So I have that equal. I'm just going to multiply straight across 100 times 0.621. So we're going to move that decimal place over to 62.1. And 1 times 1 is 1. Now I'm going to go back and look at the labels that remain, okay? Kilometers were canceled, miles is left. Hour, that's it. That's all that's down there at the bottom. So it converts to 62.1 miles per 1 hour. Let's do another. Sample 3. Convert. This one's going to be a little heavier. Of course, we're going to get a little harder. Convert 36 feet per second. So that's a rate. 2 yards per minute. Give you a second to copy that down. Right, so we're converting a rate, which is a ratio of 2 different things, distance and time. So again, we're going to take our 36 feet over 1 second, right? 1 second. Now I'm going to multiply it, and here I'm going to have to choose because I'm not just changing the distance, feet to yards, but the seconds to minutes. So I'm changing 2 units of measurement, right? So I just have to choose one. I'm going to choose the distance first. And I know because I want to move away from feet, then I'm going to put feet in the denominator here so that they cross cancel each other out. Okay. Then I've got to think, well, I'm moving towards yards. So I actually know this unit of 1, right? That in 1 yard, there are 3 feet. That's equal to 1. I can multiply by 1 and not change its quantity, but I can convert the units, right? Okay, so that is working for me. I went from feet to yards. Now I need to address the time issue that we have seconds, and I don't want seconds. So now my unit multiplier is going to have seconds in the numerator so that these cross cancel. Okay, there we go. And I'm trying to get from seconds to minutes, right? Okay, well, I happen to know that there are 60 seconds in 1 minute. That is equal to 1, right? So it's not going to change quantity. It's going to change the label, though, because now these seconds canceled out. And so what remains are the yards and the minutes as far as a label. And what we get when we multiply our numerators, I've done this ahead of time, so you don't have to. Okay. And the label that remains again, yards, per minute. So now all I have to do is simplify it or reduce it, okay? 720 yards per minute. That's how we convert them. Okay. All right, we're gonna do one more, and this one's kind of long, right? But I always need to do at least one complicated one before you move on to your practice, okay? So 4th example. We're gonna convert 75 meters per second to miles per hour. So we're changing our distance from meters to miles, our time from seconds to hours. Okay. Now there's lots of different ways you can do this. For me, I usually try to just do a little at a time because those are the ones I remember. I remember the small ones. I try to get bigger unit multipliers because it might save me some time, but usually mess that up. So I'm going to show you kind of the safe bet is to take it a teeny step at a time. 75 meters per 1 second. So M for meters, MI would be miles, right? And again, my goal is to move away from meters and move away from seconds. So I'm going to choose the distance first. It's just a habit I usually do. where I want to get rid of meters. So I'm going to put meters down here, right? And then I'd like to get to miles. Let's say I look at my conversion sheet though, my table, and what I have is that 1 meter is 3.28 feet. Maybe I don't have a conversion on my chart that gives me it in miles. That's okay, just one step at a time, right? So we got rid of meters, we've gone to seconds and feet right now. I'm gonna do another unit multiplier because again, it's not feet that I want, it's miles. And hopefully living in Colorado, we know that there are 5,280 feet in 1 mile, since we are the Mile High City, right? So MI for mile, right? And now my feet have canceled out and I am to miles, which is exactly where I was trying to go, right? So all I have to do now is go back and convert the unit of measurement that's dealing with time for seconds. So again, I'm going to choose a unit multiplier that helps me eliminate the seconds. So I'm going to put seconds in the numerator so that these will cross cancel. And as a label. And here's where I would probably just go to minutes because I don't want to make a silly math error, okay? Because I'm pretty sure I know there's 60 seconds in 1 minute. Okay. Well, minutes is not where I'm going. I want to get to hours. So that means I have to do an additional unit multiplier. That's okay, trying to get rid of minutes and convert that to hours. And in the same way I knew this, I know there's 60 minutes in 1 hour. Now these minutes cancel out. The label that's left is hour, which is what I'm trying to get to right here. Okay, so I've got my correct label of miles per hour, right? I'm going to put this down here since I've run out of room. And I use a calculator, which I should. 75 times 3.28 times 1 times 60 times 60. 885,870 miles in 1 times 1 times 5280 times 1 times 1 over 1,280. Okay. I take my calculator and divide that out. I'm going to get 167.78 miles per 1 hour. So I've done that conversion now. Okay. Okay. Hopefully, you know, with those 4 examples, it's enough to get you started. You don't have a lot to practice. You know, if you need to come back and refer back to this, feel free to do so. Can be kind of tricky at first. You'll get better by the time you're at the end of that worksheet, okay? So now you gotta find that green worksheet, good luck. If you need anything, you should email your math teacher, okay? All right, bye guys, stay safe.